so nice to be with you guys again. Hello, Ntlafatso, Sihle, Zayan, Sam. Welcome back. You ready to do some trig?
Yes, ma'am.
Awesome. Who else is here with us? Tisetso, Phoebe. Oh, it's so nice to see you guys again. I'm so glad you're joining me on this course. Welcome back, everybody. Okay, so you know how things work. Hopefully you've still got your same book and your calculator. You absolutely have to have your calculator for this section, okay? So, yeah, maybe not today. Well, mind you, maybe today, but yeah, definitely in the future you have to have your calculator. Yeah, and then we'll get started on the do now. Tutuka, Jared, Inam, welcome back. It's so nice to see you guys again. Thanks for joining us. Who haven't I said hello to? Naleti. Okay, so the first, the do now should be quite easy for you guys, or at least I'm hoping it is. Theorem of Pythagoras. Okay, so it's important for us with trig because we're going to be talking about right angle triangles in grade 10. So yeah, being able to calculate lengths of sides using Pythagoras is important. Anyway, you guys get started on that and we'll just wait a couple of minutes and then we can get underway. Okay. Oh, I didn't open the chat. Oh, thanks for all the nice messages. Cool beans. Excuse me. Okay, I see Harrison, you back with us as well. It's so nice to have you back. Nizol, nice to see you back here with us. Welcome, Katlejo, Nusanda. I think I've said hello to everybody now. Karabo, welcome back. Anam as well. Oh, and David. Hello, David. Sorry, I didn't see your name on the thingy. Sorry, David. I'm so glad you're back with us too. Okay, so it's 5 past 5. I'm sorry I'm interrupting you. How did the theorem of Pythagoras go? I didn't give you the rule, but by the time you get to grade 10, they kind of expect you to know that. But anyway, how did it go? There was a purple one and a pink one. Was it okay? Thumbs up, thumbs down? Remember theorem of Pythagoras from grade 8 and 9? It went well. Okay, good, Harrison. Everybody else? Nazol, you say okay? All right, so I'm gonna, Sam, okay, you said fine. David, you said yes. Okay, so cool beans. Thanks, Nolwazi. Thanks, David. All right, so for the first one, I got 10 as an answer. KM is 10. If you also got 10 as an answer, will you give me a thumbs up? Cool, Phoebe. All right, let's see. Okay, Harrison, Phoebe, David. All right. Oh, good. Okay, well done. Cool, Jared, Sam, so. Okay, perfect. And then if you got a chance to do the pink one, hopefully you got 7 as an answer. And if you did, then you can give me a thumbs up. Cool, Harrison. Okay, Phoebe. Okay, so it's only Harrison and Phoebe that have done thumbs ups there. Did the others not get a chance to do it? Thanks, so. Thanks, Nazol. Okay, Jared, perfect. Well done. Okay. Is there anything that you would like me to explain with regards to Pythagoras? Oh, thanks, Akila. Welcome. I can't remember seeing your name in the previous course, so welcome and hope you'll be happy here with us. Pelisa, welcome back. Nice. Is everybody okay with why x would be 7? Are there any questions? Oh, your screen is black. I'll ask Tula to help you with that. David says his screen is black, Tula. I'm not sure what's going on.
Yeah, I'm not sure either. Maybe David, if you're using a browser, you can refresh, and if it's an app, just quickly exit and then come back, and then just pop a message on the chat if it's still blank. And I'll type a message to Lucinda as well.
Okay, perfect. Cool. All right. So let's get into trig. Again, before we get started, is there anybody who hasn't done trig at school? Maybe you can just pop a me, if that's you, into the chat. Is there anyone who hasn't done any trig at school yet? Okay, cool. So at least this is something we're going to be going. We just started it yesterday. Okay, Nolwazi. All right. Then I hope that we keep up with your school. We might go a little bit further ahead, a bit faster than what your teacher is, but at least then you'll know what's coming. Everybody else done trig then, I assume? I have, but you're not good at it. Okay, Nazol, well, that's fine. That's why we're here. Okay, not a problem. Before we start, David, you haven't done it. So you've been doing it for a week now. Okay, Phoebe. Okay, so at least you're into it. Okay, so does anybody actually know what trigonometry is? Like when your teacher says to you, we're now going to be doing trigonometry, what does your teacher actually mean by that? Did they explain to you what trigonometry is?
Ma'am, according to me, trigonometry is the relationship of triangles.
It is. It is quite right. That is, yes. Harrison in grade 10, well done. That's perfectly true. Okay, Nolwazi, you said no. Okay, so I think it's always nice for us to be able to understand what it is that we're doing. And you're quite right, Harrison, in grade 10, it's all about right angle triangles. But next year in grade 11, it's not just about right angle triangles, and we extend trig. Oh, wow. Well, Sihle. mathematics concerned with specific functions of angles and their applications to calculations. There are 6 functions of an angle commonly used in trig. Indeed, that's quite right. Okay. Yes, I agree, Phoebe. That is a very comprehensive description, C-Claire. Thank you. 100%. Okay, so it's a study of triangles and how the lengths of sides are related to the size of the angle opposite that side. So let's just talk a little bit about how triangles are named and what we mean by a corresponding side. Okay, so if we have a look here at triangle ABC, it's a right angle triangle, the right angle is at A, all right? My focus angle, my reference angle that I'm working with in this triangle is at C, and it's been labeled theta. All right, so theta is like a letter, but we use it to describe the size of an angle when we don't know the size of that angle. So we could call an angle X, we could call an angle Y, we could call an angle A, but there are just some Greek letters that we use for angles as well. So we don't use them normally in algebra, but we just use them in trig. All right, so now the side that is colored purple, all right, it's always opposite the right angle. Okay, and because the angles of a triangle add up to 180 degrees, if there is a right angle, the other 2 angles have to be acute angles. They have to be smaller than 90. That means that the 90-degree angle is the largest angle in the triangle, and thus opposite it has to be the longest side. Now, right angle triangles is a special name for the longest side. What's that called? A weird name. Can anybody put it into the chat for us? What's the longest side in a right angle triangle called?
Hypotenuse, ma'am.
That's it. Oh, wow. See, Claire, you are on a roll today. Very nice. Quite right. It's called the hypotenuse. Okay. So if you were looking at a right angle triangle and you're not sure what side is opposite the right angle, we always call it the hypotenuse, and it's always going to be the longest side. Okay. Now, something else. All right, if I'm talking about my reference angle theta being over here, then I would say that side BA, the side over here, what word would I use to describe the position of BA in relation to theta?
It's the opposite.
It's the opposite side, quite right. Okay, so it's the opposite side. So opposite to theta in this picture is side AB. And what would we call side AC?
Adjacent.
Adjacent. Okay, so did you know that the word adjacent is just a fancy way for saying next to? Okay, so next to the angle, opposite the angle, and then the hypotenuse. The other thing that's important, and I suppose is a little bit more important next year than it is now, is we can also, so just like we can name angles with a letter. So if I talk about angle C, I can talk about it like that. But then opposite angle C is side little c. So little c is side AB. So I can also write AB as C. Opposite angle A is side little a. So that means that I can call side BC little a. And opposite angle B, so opposite this angle over here, is the side AC. So if I've got side AC, I can also call it little b like that. Okay. In maths, remember, two capital letters next to one another is a way that we write a side. Okay, so if there are two letters next to one another, it has to be a side. If there are three capital letters and the one in the middle is wearing a hat, then it's an angle. Okay, so if I say BCA like that, then I'm talking about an angle. Or I can just name an angle with one letter and then I can put a little hat on it like that. Okay, so I think sort of how things are named and what they're called is also important for us. All right, so now let's jump into this triangle over here. And now that we have had a look at naming the sides of triangles, opposite, adjacent, and hypotenuse. Let's apply it to what we see here. So now I'm going to rely on you guys to help me with the answers. Okay, so you can either unmute your mic or you can pop it into the chat. Which side is adjacent to theta?
CB.
Side CB.
Indeed, side CB. Good. All right. Next question. Which side is opposite theta?
Side
Side
AB.
AB.
Well done, grade 10s. Very nice. Which side is adjacent to alpha?
Side AB.
Indeed. Is everybody else okay with that? Side AB is adjacent. So in other words, next to, sorry, angle alpha is adjacent to AB. Which side is opposite alpha?
Side CB.
Good. Well done, everybody. Okay. Alpha, yes, Kaklejo. So this funny symbol over here like that is alpha, and it's spelled actually like that. And then theta, just so that you know, theta is a symbol like this, and we spell it like this. Not that you ever write this out in maths. And then another symbol that we also use for angles is this one, and it looks like that. So it's like a B with a long tail, and this one's called beta. Okay. So these are letters of the Greek alphabet. I don't know why we use them here, but we do. Okay. All right. So now you understand what we mean by the words adjacent and opposite. Okay, Katlejo. All right. Makes sense. Now let's talk about SOHCAHTOA. And some of you were saying SOHCAHTOA earlier, which is perfect. All right. So SOHCAHTOA is a way for us to be able to remember the trig functions or the trig ratios. Okay, so the sine function, although if for some reason we leave the e off the end, the sine function is defined as a comparison or as a ratio between the length of the side opposite that angle and the hypotenuse. So the word sine cannot exist unless it's related to an angle. So you can't just have sine on its own. It doesn't make any sense. So it always has to be in relation to an angle. Okay, so opposite would be the side opposite that angle. Hypotenuse would be the longer side in the triangle. Cos theta would be adjacent over hypotenuse, and tan theta is opposite over adjacent. So that's where we get the SOH. So sine, opposite, hypotenuse. Ka, cos, adjacent, hypotenuse, and toa comes from tan, opposite, adjacent. No problem, Katlejo. So these are what we refer to as the basic trig ratios. Okay, so there are three sides in a triangle. All right, so what we are doing is we are talking about the relationship between the three different sides with respect to a specific angle. Okay, so the sine of an angle, right, this value over here, sine theta, is a measure of how long the side opposite this angle is divided by the length of the hypotenuse. Okay, so if I had, we were working with right angle triangles in the beginning, right? So if I had, absolutely, SOHCAHTOA is amazing. And there's so many like funny little mnemonics that go with it as well. But I think SOHCAHTOA is great. Oh, that is the most dreadful right angle triangle I have ever drawn in my life. I'm so sorry. Okay, so that horrible line is supposed to be the hypotenuse. There's angle theta, all right? So if I call this side little a, and that side little b, and that side little c, when I'm talking about the sine of theta, I am comparing the length of the opposite side, which in this case is a, divided by the length of the hypotenuse, which is c. And then what we can do later on is we can give A and B and C values, and we can actually calculate what the trig ratio is. Okay, so these over here, yes, absolutely, it's always in the corner. So here's your right angle triangle over there, and that can be theta. But then see, if I want to define what this angle is over here, okay, unless it's a hypotenuse right angle triangle, I can't call it theta. Interestingly enough, does anybody know how big this angle that I've just colored in here, do you know how big that angle is in terms of theta? Does that make sense? In terms of theta, how big would this angle be? You're on the right track, Nizol, but it can't be 90 because this one's already 90. Remember, the angles of a triangle add up to 180 degrees.
I think it's 30, ma'am. 45.
Okay. All right, but if it's 45, then it means that theta has to be 45. Okay, there we go. Nizol said the right thing. Okay, so that's what we were looking, well, that's what I was looking for. I hope I made myself clear. It would be 90 minus theta. Does that make sense, grade 10s? Does it make sense that that angle in the corner there would be 90 minus theta? It doesn't. Okay, no problem. Phoebe, yes. All right, we're going to get back into SOHCAHTOA now. Let me just explain. Okay, so Katlejo, just 2 seconds, guys. All right, so Katlejo, what we're talking about is this, right? We have a triangle, and hopefully a far better triangle than the one that I just drew. Okay, if this angle over here is theta, let me pretend that this is triangle ABC. The angles of a triangle always add up to 180 degrees. Okay, Inam, so I'm explaining it now. So we've got angle A plus angle B plus angle C, and that adds up to 180 degrees. Okay, sum of angles in a triangle. Now I'm going to substitute. Okay, I don't know how big A is. That's what I want to calculate. I know that B is 90. I know that C is theta, and it equals 180. So now, there we go. Yes, 90 plus 90 equals 180, quite right. So now what I want to do is I want to move the 90 and the theta over to the other side. So if A is the subject over here, and I take this plus 90 over to the other side, what's it going to be on the other side, Inam? Is it still going to be plus 90?
Minus 90.
Indeed, exactly. I must say minus 90 on the other side. And what, Inam, what's going to happen to plus theta when it goes over to the other side? Is it still going to be plus theta? No, exactly. So when it goes over to the other side, it has to change its sign. Okay, minus theta, quite right. Negative theta, yes, see, Claire, perfect. Okay, so here I've got 180 minus 90 minus theta. And then when I simplify that, 180 minus 90 is 90. And then I've got to bring down my minus theta. Remember, I can never add and subtract unlike terms in maths. Okay, so that's why angle A in this case is called 90 minus theta. And that's going to become really important for you guys next year. But I think it's nice to hear people talking about this now. All right, okay, so let's go back to what we were talking about. So SOHCAHTOA, so there are our basic trig ratios. All right, so the cos of any angle is going to be adjacent over hypotenuse. So in the case of what we've got over here, sorry, I haven't written this very nicely, have I? Okay, so if I wanted to know cos theta, as it relates to this triangle over here, cos theta would be what side over what side?
Adjacent over hypotenuse.
Exactly. All right. And in this case, what is the adjacent side called? The adjacent side is called?
B.
B, indeed. Okay, good. Yes, Nizol. Yes, Sihle. It's called B. What's the hypotenuse called?
C.
Good. Well done. Well done, grade 10s. Okay, and then the third B over C. Quite right. Okay, and then the third basic trig ratio is the tan of angle theta, and that compares the opposite side to the adjacent side. So in this case, we would write this as A over. Beautiful. Okay, all right. So now I must stop talking and let you guys do a little bit of work. What I had done is I put this together for you. Let's just get rid of that that's on the side here. Okay. So now what I'd like you to do is I'd like you to write down sine theta, cos theta, tan theta, and sine alpha, cos alpha, tan alpha. Okay, you can draw that triangle just quickly into your books, and you can label angle A as alpha and angle C as theta. And let's see how you go with naming the sides. So now what we're going to do in this case is we can use capital letters or we can use small letters. Maybe we just work with the capital letters that we've got. Does everybody understand what to do? Do you want me to do one example with you?
Yes, please, ma'am.
Okay, no problem. All
Ma'am,
right.
can we please draw this first?
Okay, so should I
Yes,
just
ma'am.
wait?
Yes, please, ma'am.
Okay, all right, that's fine. So you draw
Yeah.
that quickly. All righty, Nam, I'll do one example with you, no problem. So you guys just get that triangle down and then we can get started. Cool, Sihle, so you've got it down, all right. Okay, so let's use pink for the pink angle, okay? So if we are talking, cool, Zayon, thank you for letting me know you were ready. All right, so if we are talking about sine theta, cos theta, tan theta, this angle that I'm busy coloring over here, that is our focus angle, our reference angle. It is with respect to this angle that we are now working. All right, because clearly it depends on where we are, what's going to be opposite us and what's going to be next to us. Okay, so from where theta is positioned, sine theta is the side opposite it, which in this case is called side AB, divided by the side that is the hypotenuse opposite the right angle, so opposite angle B, that would be side AC. So sine theta, as it applies to this triangle, sine theta is AB over AC. Does that make sense? Opposite over hypotenuse. Is that okay? All right. Good stuff. Okay, so Akila, Zayon, everybody else, do you think that you can do cos theta, tan theta, sine alpha, cos alpha, tan alpha? And I'll give you a couple of minutes to try that. Good stuff, Pelisa. Good stuff, Sam. Okay, cool, Phoebe. No problem. All right, and even if you get it wrong, so what? Oh, Harrison, you finished already. Okay, no problem. Yes, Sayon. Do you want to ask me a question? David, you done already? Oh, wow. Okay, Speedy Gonzalez. All right. Done, Anam. Well done. Oh, you were just correcting yourself. Okay, well done. Okay, Akila, you finished. Hey, you're on the ball, grade 10s. I'm amazed. Well done. So we've got some more questions over there that we're going to go and quickly look at. Okay, so this was easy. Okay, Phoebe. All right, are you done, Phoebe? Oh, awesome. Okay, all right. So now I'm just going to scroll up here. Who said done first? I think it was Harrison. Okay, all right. Harrison, will you please tell us what you think cos theta is equal to?
Cos theta is adjacent over hypotenuse, which will be CP over AC.
Perfect. Okay, well done. Okay, so you guys can mark this as we go. Who was done next? Zion was correcting myself. David. Okay, what's tan theta, please, David?
Tan is opposite over adjacent, which is AB over CB.
AB over CB. Absolutely. I'm sorry, Celia, I didn't see your message until now. My apologies. Opposite over adjacent. Do you want to? Yes.
Can I ask, ma'am? Since you're writing the AB over AC, what do the fractions next to those represent?
That's fine. So all I'm doing over here is I'm just putting in brackets opposite over hypotenuse. And then over here, and then here, adjacent over hypotenuse. And then over here was opposite over adjacent. Okay, does that make sense? Okay,
yes,
so Katle, okay, good. See here, I said, it doesn't matter. If Harrison says that this line at the bottom over here is line CB, and you come along and you say it's line BC, it's exactly the same thing. It doesn't matter. Okay, it really doesn't matter. Okay, so Katlejo, you did the opposite. Okay, so there's a name for that as well. All right, no problem. There's a name for that. There is a name for the opposite. Okay, it's called the reciprocal. So always talk to yourself when you're doing this, Katlejo. Okay, so if it says sine theta, find the angle first, then go to the side opposite it. That's the one that's got to go at the top. Okay, and then the hypotenuse is the one that's got to go at the bottom. Okay, so now see, Claire, did you in there, you wanted to do tan. Do you want to do tan alpha or do you want to do sine alpha? Choice is yours. No problem. Oh, you don't want to? Okay. All right, Clear, no problem. I'll pick on somebody else then. Okay, who else was Aquila? There we go. Aquila, what did you say sine alpha was? Sorry, I'm just getting my pen ready. You don't want to. Oh. Is there anybody else? Oh, brilliant. Okay, Phoebe, go for it. Even if you get it wrong, there's no judgment. We're all friends here. I'm not going to judge you. Okay, Phoebe, fly off. What did you get? CA over AB. Very good suggestion, but in relation to where this angle is now, okay, this side over here, side AC, irrespective of whether we are talking about the 90-degree angle or theta, you can try Harrison.
Okay, ma'am.
Okay.
So if we're now focusing on another angle, the adjacent and the opposite change, right?
Correct.
So now sine, is it sine theta what?
So sine alpha.
Yeah, sine alpha is gonna be CP over AC.
Indeed. Okay, 100%. I couldn't have said that better. Okay, David, the next one belongs to you. I just want to explain this to everybody. Okay, did you guys hear what Harrison just said? Okay, and it was a cos alpha is AB. Okay, Nazol, you've got it. Quite right, 100%. That's perfect. David, tan alpha belongs to you. Okay, so the hypotenuse is always the hypotenuse, grade 10s. That never changes because there's only one side that can be opposite the right angle. So the one that I've colored in purple, the hypotenuse is always the hypotenuse. But what Harrison said, where he said that depending on which angle you're looking at, opposite and hypotenuse change. And he's quite right, because in relation to the pink angle where theta is, this side AB is the opposite side, and side CB is the adjacent side. But now it swaps around when we talk about the other angle. So over here, when we're talking about angle theta, side AB is no longer the adjacent side. Okay. Side CB is no longer the adjacent side. Okay, so side CB will be the side opposite, and AB is the side adjacent. Okay, cool. I'm glad you understand. Is that making sense to everybody else? Okay, so as Nozol said, no problem. So cos alpha is adjacent AB over hypotenuse AC. Okay, Katlejo, I will say this one more time. Oh, good, please. I'm so happy. But Katlejo, I'm going to help you with the next one, and let's just get everybody started on that, and then I can help you with that. I can explain while they're busy working. Okay, so now, David, tan alpha is yours. Take it away. What should we write?
CA over AB.
How much?
CA over AB.
CA over AB. All right. So David reckons this is CA over AB. Who agrees with David that tan alpha is going to be CA over AB? Or has? No. Okay. So make a suggestion.
Ma'am, I think it's AB over BC.
You think it's AB over BC. All right. Let's write down your suggestion. Tan alpha is AB over CB. Okay. Anybody got something different? Phoebe, what are you saying? You're saying tan alpha is equal to CB over. Okay, so over AB, yes. Okay, so Harrison and Anam and Phoebe, you are correct. Okay, so it's supposed to be CB over AB. All right. Almost right. At least you had this in the correct place over there, but then we had the wrong side there. And then here, unfortunately, we had the adjacent side, and this side over there is the opposite side. Okay, so unfortunately, those two over there are not correct. Okay, so what you need to do is you need to change your perspective. Even if you just look at it like from a different perspective like this, sometimes it helps a little bit. Okay, so opposite angle alpha is side CB, but opposite angle theta is side AB. Right, so if we're talking about the tan of alpha, this is our focus angle. That is the angle from which we are working. So tan is opposite over adjacent. So opposite is CB over adjacent is AB. So now that is correct. Okay, I hope that's making a little bit more sense. Let me move down over here. All right, and here are some questions for you guys to fill out. Okay, so you need to fill in where the little yellow blocks are. Okay, so I've given you a triangle. All the questions that where you need to fill in the little yellow blocks are based on this triangle over here. Is that big enough? Make it a little bit smaller. Okay, maybe what I should do, so you can get started. I think what I should do is give these numbers. So that'll be number 1, that'll be number 2, number 3, number 4, number 5, number 6. Okay, so you guys try those quickly. And when you're finished, you can pop a done or a thumbs up or whatever into the chat. Okay, well done, Erickson. Good, Karaba, well done. And David, excellent. Okay, Lysander, well done. And Pelesa. And Kelebochile. Oh, good. I don't think I said hello to you in the beginning. Okay, so let's get started on, okay, Katlejo. All right, well done, well done. And you know what, even if you get them wrong, it doesn't matter. That's why we're here. We're here to learn and we're here to improve. We're not judging one another. This has to be a nice space where we can all share our ideas and say what we think. Good, Sam, done, nice, Phoebe. All right, and if you make a mistake, so what, we fix it. Okay. All right, so number one, Sam, do you want to tell us that one? What is the hypotenuse called in this particular triangle? What's it called, Sam?
B.
Yay, well done. You've got it. Okay, number two, Phoebe, sine theta is? A over B. I quite agree. Well done, Phoebe. Who's next? Katlejo. Okay, don't stress. Doesn't matter if it's wrong. The side adjacent theta is called what, Phoebe? I mean, Katlejo, sorry. You can do number 4, Nizol, with pleasure. Okay. Katlejo, are you okay with this? Side adjacent to theta is called? Well done, Karabo. I agree. It's called C. Okay, so number 4 belongs to Nizol. Go for it, Nizol. Tell us what you wrote. Nizol says C over B. I quite agree. That's exactly what I got. Okay, we're nearly there. We're nearly finished. Okay, so who else can I call on? All right, Kelebochile, I haven't asked you yet. Number 5, the side opposite theta is called?
B.
B. All right. A, Entle, yes, I agree. That's what I said as well. It's called A. Okay, so Kelebohile, I know it's difficult. Well done, Enam. Yes, that's right. Yes, Entle, perfect. Okay, I know it's difficult to see in the beginning and it's no stress at all. Okay, so here's angle theta. So the side opposite it is called A. All right. Good. Well done, Enam and Entle and everybody else who got that. Who else have I not got? Pelesa. And Lusanda, I need to ask you a question as well. Okay, Pelesa, you do number 6 for us, please. What did you say here? So this is the tough one. Shame. Sorry, I'm asking you. So the what of theta is A over C.
Tan.
10, indeed. Well done, Pelisa. That's perfect. Okay, it is 10. Okay, well done, NM and Karaba. Okay, perfect. Well done. Okie dokes. Well, we might have a little bit of time left over. We can go and talk about something else. That's not a problem. So now there are some blocks for you guys to fill out here as well. I think you might be able to do this really quickly. Okay, so again, I have given you a right angle triangle and I have put yellow blocks over certain things. Okay, so now you guys need to fill in what goes in the yellow block. Oh, I'm so glad, Sihle. And it's nice because there's colors too. I'm so glad you're enjoying it. Good. It's important for maths to be fun. Oh, you can't see the triangle in him. I don't know. I'll move it a little bit over and let me make it a little bit bigger. Is that better? What's the difference between alpha and the other sign? Okay, so Katlejo, the one angle is called theta. No, Karabo, alpha and theta are not the same in this case. Okay, they're different. All right, so this angle over here, let me just use a color. Okay, so this angle down here, that's pink. This is angle theta. All right, this angle up here in this corner, that's purple. This is angle alpha. Oh, it was you that zoomed. Okay, all right. So this should be big enough for everybody to be able to see. So let's see how you go with these 4 questions. I know you need to think. Okay, it's not just quick, easy, but it's okay. Just give it a try. Can I explain the difference? Absolutely, Karabo. Okay, so while everybody else is getting on with that, let's just talk about this triangle as we see it over here. So because I have, what I'm saying in this situation is that this right angle triangle is an scalene right angle triangle. Do you remember the word scalene from grade 8 or grade 9, Karabo? Have you heard the word scalene before? Cool. Okay. So when we describe a triangle as scalene, what we are saying is that all 3 sides are different lengths. So in other words, the hypotenuse is a certain length. The second side is a different length. And the third side is completely different. So when you've got a triangle like that, what you will find, Karabo, is that the biggest angle is opposite the longest side. The biggest angle is opposite the longest side. Okay. If this angle over here is the smallest angle, it will be opposite the shortest side. And then this one over here, that's the medium-sized angle, it will be opposite the medium length side. Okay, so in triangles, all triangles work like that. So the biggest angle, sorry, the longest side will always be opposite the biggest angle. The longest side is always opposite the biggest angle. Okay, all right, David, cool beans. We're going to look at the answers now. The shortest side, it was Harrison. And I did it on purpose because I wanted to give you guys a little bit of a challenge. Okay, good. I'm glad it challenged you. Hopefully not too much, but a little bit. All right, and then the side that is the shortest, sorry, the angle that is the smallest will be opposite the shortest side. So what I'm trying to say in this right angle triangle over here is that side A and side C are different lengths. And that's why theta and alpha have got different letters, okay, to indicate that they are different sizes as well. All right, I hope that explains things adequately. All right, and some people are already finished. That's amazing. Okay, so let's go and have a look. You get it now. Cool. Okay, so perfect. Sam, excellent. Well done. Okay, so who's going to do sine alpha for us?
Can I try it, ma'am?
Go for it. All yours.
Ma'am, it's A over B.
I agree. Okay. All right, Harrison, you said you don't mind doing one. Yes, Nizol, the last one's yours. Perfect. Okay, so Harrison, you do the second one for us. Yes, Entley, you do the third one. Perfect. Okay, so Harrison, the cos of which angle is A over B? I don't know if Harrison can hear me. Harrison, can you hear me? You're going to do this one. So the cos of which angle is A over B?
Theta.
Indeed, theta. Yes, David, perfect. Okay, then the third one, that was Entley. Go for it, Entley. The tan of which angle is C over A? Okay, so David says theta, Entley says theta. Good, well done, perfect. Okay, good job. All right, and now the last one. Okay, and we said, Lusanda, you said you were going to do the last one. Okay, so off you go, Lusanda, you do the last one for us. Okay, so Lusanda says sine. Nizol says cos. Phoebe says cos. You also say cos, okay. And I also said cos. All right. Don't stress, Lusanda. Okay, it takes a little while to understand this. The reason why everybody else was saying cos, all right, is I had done that with a question, hadn't I? Okay, so if you look at where, it's okay, Harrison, no stress. I thought you'd probably lost your connection. It's not a problem at all. Okay, so if we look at where CB is, and then where we look at B is, so B is a hypotenuse, all right? Whoopsie daisy, why did I do that? Okay, so B is going to be the hypotenuse, all right? If we look at side C, all right, C is next to or adjacent to alpha. So that's why everybody was saying cos alpha. Okay. Are there any questions? Anything anybody would like to know? Nope. Okay. All right. So we've got a couple of minutes left. That's fine, Sam. Fine, Phoebe. I just want to mention something to you, which we're going to be doing the next time. All right. And in the beginning, was it Sihle who put that fantastic explanation of what trigonometry is? I just want to go back and just talk a little bit about that before we end off. Okay. So Sihle, I think, mentioned to us that there were more than just 3 trig ratios. Okay, so there's sine theta, cos theta, and tan theta. All right. When you write the word, yes, it was you, Sihle. When you write sine theta, you are actually writing sine theta over 1. So did you know that it was possible to write something as 1 over sine theta? So instead of sine theta being over 1, we can write 1 over sine theta. Doesn't mean the same thing, okay? Did you know that? Okay, so Sihle knew that. All right, so Sihle, what is 1 over sine theta called?
Cosine.
No, this is cosine over here, okay? So
What? Cosec.
cosec is correct. So cosec theta, that's it, Sihle. Cosec theta is 1 over sine theta. And does anybody know what this word, what do we call these over here? This has actually got a name. Does anybody know what the name is?
Cosec, it means hypotenuse over opposite side.
It does. It does. That's perfect. I couldn't have said it better. Well done. Okay. So these are called the reciprocal ratios. Okay. So cosec is the reciprocal of sine theta. Okay. So cosec, as you had said, is going to be hypotenuse. Not unfortunately not, Sihle. So cot belongs to tan. So cot theta is the reciprocal of tan theta. Anybody know what the reciprocal of cos theta is called?
Sec.
It is sec theta. Good, Pelisa. Yes, that's right. Okay, so these are important in grade 10. We don't really work with them in grade 11 and grade 12, but these are important for us to work with this year. So just very quickly, if I said to you that sine theta is A over B, what would cosec theta be? If sine theta is A over B,
B over A.
It B over A is perfect. Well done. Okay. Unfortunately, Nazol, there isn't a slang for that, but I've got a nice slang for you later on with SOHCAHTOA. It's another way of remembering when we do it on the Cartesian plane, but unfortunately not. This is something that we just need to learn. Okay. So cosec is the reciprocal of sine theta. Sec theta is the reciprocal of cos theta, and cot theta is the reciprocal of tan. Okay, so cot is actually a shortening for cotangent, and then the tan function is there we go. Oh, look at that. Harrison made one for us. What did you say, Harrison? CHO. So cosec, hypotenuse over opposite. Excellent. Okay. SHA. Sec, hypotenuse, adjacent. And then the last one. I know, isn't that brilliant? So the cot of the angle, and you said adjacent over opposite. There you go. Okay, well done. Oh, and that brings us to 6 o'clock. Okay, so we'll talk a little bit more about reciprocals next time and about special angles. And please remember to bring your calculators because we're going to be doing a whole bunch of calculator work. Okay. I'm so sorry. Oh, Katlejo, did you not enjoy the lesson? Do you feel damaged? Are you sad? Oh, I'm sorry. Was it difficult? Okay. All right. Well, you just do your best, okay? I know it's difficult if you haven't done this at school, all right? But it will soon make a lot of sense to you. Was everybody else okay? Any last questions? Yes, we are in a. Okay. You all right, Seon? All right. Cool, Phoebe. Okay, guys, I'm going to hand you back to Tula now. Well done, grade 10s. All right, you're wonderful. All right, great work. Excellent.
Hello, grade 10s. You guys have been great. You guys have been great. It's really unfortunate that we are out of time, but remember that we're also here. We're also here on Thursday, and we're going to be continuing trigonometry. So even if you couldn't catch everything this evening, that's okay. We're going to continue, and you're going to get it eventually as you practice on the Watobi app, and you ask questions, and you attend these live lessons, and you stay consistent also, you know, and ask your teachers at school the questions. So hopefully everything will be fine, Katlejo, okay? Yeah, so I'm just going to quickly run through this now. Remember, we're doing trigonometry, and we just finished our first lesson, which is great. We'll be having our second one on Thursday, which is where we'll be calculating work, reciprocals, and special angles, if that's accurately. So yeah, be sure to come with your calculator once again, be on time. And as you guys have seen, it's a new topic, so it takes some time to get used to. But as you come here and you come ready to ask questions, you're ready to participate, and you do the activities that we ask you guys to do to practice the homework and stuff, you will be fine by the end of this, okay? And of course, we're gonna do the leaderboard. We haven't done the leaderboard in a while.
Okay.
And yes, these are the superstars for the week. So congratulations, Nosisa, Anam, Balesa, Nyeleti, Nian, Kanya, Sinentlandla, and Nizole. You guys are great. Thank you for taking the time to go to the app and do the activities. And I mean, at the end of the day, it's all just for you. It's all for you too. It's not for me, it's not for Lee, it's not for Watobi, but it's for you to solidify your learning, you know, for you to know that you actually understand these things, and you know, when you go to do this homework and you do the quizzes. So you guys keep rocking on. Congratulations, and I hope I'll see your names keep popping up on this list again. Yes, so, and then just so the homework for this lesson, just for you to go at home and practice, you go to the app, say pick a topic, trigonometry, as you guys know by now, and then go to trigonometry basics, and then intro to trigonometric ratios, naming and using the sides of a triangle. So watch the lessons there, do whatever quiz that is there, just to solidify your learning. You know, and since it's a new topic, especially, that's much more important than it would be, I'm thinking, in other topics. So you guys have been great. Enjoy the rest of your evening. I think that's it for me. Lee, do you have anything to add?
No, well done, grade 10s. It's always so wonderful working with you. So yes, I'm really looking forward to the rest of our course. And please, if there's anything that you don't understand, or if you just feel that I haven't explained it properly, or you've got a question, please don't hesitate to ask. Okay, I really do mean what I say. I'm not here to judge you. I'm here to help you. Okay.
Yes.
So
yes. Certainly,
that's the most important. Yeah. Anyway, have a great evening, grade 10s, and we'll see you on Thursday.
Bye, guys. See you Thursday.
Bye. Thanks, Tula.